So hi guys and welcome to another video. So today we're gonna be learning about functional programming.
There are different ways of programming. So what you have been using now is called a procedural programming. So procedural programming is basically there's a line by line. You just do your coding and then the code is executed line by line. So that's where in your game that's how it works, right? So it read from the top to the bottom and do it one by one. But as you can see, when you do such things, it becomes bigger and bigger. Even in that one file, if it's too many things, it's very hard to
Run.
It's easy for the program to run because it's a computer. It can do a lot of things together, right? But as a human, we cannot organize that as the computer does. So once the program is getting bigger and bigger, you need some other ways to organize your code to make it more human readable. And also it's easier to reuse the code somehow, because otherwise you have to copy paste the similar stuff once and once over again. So there are another two types of programming. One is called functional programming. So function programming FP, that's focus on immutability and avoiding side effects. You make code blocks group together, and then each of the block inside does its own job. So it's not touching anything else, but just inside itself. So that way you organize your code in a way that's easy to be read as part, and then it's like Lego. You put different Lego parts together, and then you make your whole project. Okay. The other way is called object-oriented programming, OOP. That one we will talk about later in later episodes. Basically, for now, you just need to know like object. It's focused on objects. So object is like in a real world. Something is an object. Everything like is an object. For example, this is a phone object, right? So the object.
Aren't we subjects?
Yeah, human is like an object, and you are part of the human. So.
And Adam. Adam makes up everything and it's an object. So everything is an object.
Yeah, something like that. So atom is an object, and then use atom to combine to make other objects. So that one we will talk about later.
Oh.
So it focuses on like data abstraction and those things. Okay. Now, since this episode we talk about functional programming, so we need to learn what is a function. Function basically it's like special kind of code blocks. It wraps your code in code blocks, like doing the same thing into one function, and you give it a name. It's like variable. It takes inputs and then returns something as an output. So it's very straightforward. It takes something in and then output something out. But there are special cases. It doesn't take anything. It's an empty input. That's okay. There can be empty, like nothing output. That's also okay. But usually it's about input and the output. Special type of variable. Basically, you can think it's a name of a block of code. It can be called later with the name you've been giving it. So we can have a look at the example here. What is a function? What is a Python function? So how you create a function is like you say this, def, like definition, def. Define a function that's the name of a function, and then with that, afterwards it's a block of code. So it can be multiple lines of code here. So this is the simplest way of defining a function. As you can see here, there's no input, there's no output. So that's just a very simple, straightforward function, right? How you call a function, I think you've seen that before with brackets. So you've seen everywhere, like when we coding the game, there a name and there's a bracket. That's how you call the function. So you've been using functions all the time, basically. but now it's time to make your own functions. So the arguments is the stuff that's the input. As you can see, when you define the function here, you can put some variable names here. So this is where the input is gonna get inside the function. So for example, here you can see it is a my function. The argument is a f name. So when you call the function, instead of the empty bracket stuff, it actually can take whatever you name here. So if you say this is email, the email, this string will be passed to fname, this variable, and the fname variable will be available inside the function. So this basically will print email refness. Okay, so that's how it works. It takes the input, and then the input can be used inside the function. And there can be any number of arguments or inputs for a function. So if you want like 10 or 20 even arguments, that's okay. So for example, in here, it takes two arguments, so two inputs, first name and last name. So you say, when you call the function, you can also use the comma to separate your inputs. So that way, inside the function, you can use both of the inputs from outside. Okay, and if you name two arguments for the inputs, you can not only pass one, otherwise it will be an error. Okay. These things can be later, so there's other ways to make the inputs useful. Okay, so these are more advanced usage of the arguments, so they can take different numbers of arguments, whatever. Those things you can use later, but usually we just use a static number of functions and inputs arguments. This is also kind of useful because when sometimes you want to set a default value for your input. That way, even people don't pass anything, the arguments will equals to the default value you passed in. So for example, here, if you call this my function without any input, it will just say I'm from Norway. Okay. Now the output part, usually you use this return to do the output. So whatever you pass to the return after the return will be returned to the outside of the function. So here, if you say 5 multiplied 3, then the outside will get my function equals 15, basically. Okay. So we'll see more of those useful things later. So next, talking about functions, we cannot without talking about the function scopes. So here. So basically scope means where the variable is available. So for example, in this example, inside the function, you have x equals 300. When you print x, it will be 300, right? Very easy to understand. But here, as you can see, if the function inside the function, so the second function in the function here, when you print x, what do you think it will get? So this is the function outside, this is function inside. If the inside function print out a variable that's from the outside function, what will this x be?
300.
Yeah. So outside variables can be
Inside
used by the inside function. So this is called a scope. So the scope is always outside, can pass into the inside automatically, basically. So outside all the functions, you can think the whole program itself has the global kind of scope. So the global scope, like here, so let's see an example like this. X equals 300 is outside all the function definitions, right? So that 300 is acceptable by any function defined after it inside the functions. So now it comes an interesting issue. Since it's acceptable inside the function, if I change the x 200 inside the function,
Since it goes down, it's gonna be 200.
is it gonna change the outside 300 or only inside?
Probably only inside.
Only inside? Let's run it and see. Yes. So inside it's changed to 200, right? So you can see here x equals 200, print x is 200. But when you call the function, it print off 200 afterwards. If you print x outside, it's still to 300. So it's not going to touch the scope outside of its range. Okay. So that's something you need to care about, because when you name the variable the same name outside and inside, when you do things differently, it will be it can make things messy, because you don't know whether you changed outside or not. You don't know whether it's used anywhere else, right? So there's a even messier way to use it, is that inside the function, if you say global x, you make the inside x global. So in this case, if you change the inside x to 300, the outside will change as well. So you can see this example here. It's basically the same as the previous example.
But now it's only 2.
Now it's 200. Because inside the function you say global x, then it will change the function at the variable outside straight away to 200.
Yeah, but if it's like in front of it, then what happens?
What do you mean in front?
Like the global x.
In front of which?
The x equal 200.
Yeah, that's what it does. It's in front of the x equals.
Wait, I mean by behind.
Behind, we can try. I don't know if anyone do that. It's error. So you cannot. So global x have to be at the beginning of the. Yeah. Anyway, so this is a very messy way to do things. So basically, this error says you cannot make it global after you have changed it to something else. Okay. So this is very messy, because if everyone doing this kind of thing inside their function, imagine this is a teamwork. Everyone has their own functions, and you have global variable. Everyone's touching it. No one knows what's it's gonna be, right? So back to our functional programming. So function programming, the idea is the function is pure, which means it shouldn't change anything outside of the function. That's what it means. Avoid shared state. You shouldn't share any kind of variable state or anything outside your function. Inside your function, everything should be pure, and you only change stuff inside yourself. You don't touch other people's stuff. That way, there's no messy kind of side effects. Data should be immutable, which means that's probably not going to apply to Python a lot, but in certain functional-only programming language, the data is always immutable. Basically means once you create a list, for example, you cannot change it. You can only give the list, the variable, the whole new list. You cannot, like, say, append an item to the list. Basically, that will, if you need to do that, you will need to make a new list that's the original list plus one item kind of thing.
But can't you delete the original list?
Yeah. Basically, that's how you do it. You delete the original, make a new list that's with the extra item inside.
Or you could copy it.
Yeah, copy it is also okay. So if later in the future we learn a pure functional language, I'll teach you more about those immutability and stuff. But for now, it's probably in Python not that much. Another very important thing is, like, if you gave the same type of input as your arguments, you should always get the same return. So that way it's very testable. You can test the whole thing without any side effects and change kind of thing. So if you use global kind of thing inside your function, it's not that pure. Then every time you test it, it will be based on the stuff outside. That makes it not the same input doesn't give you the same output, right? So that's bad. the last thing is we can use modules to manage functions. So although the examples you see here, they are defining function, they are still in the same file, right? So modules is the way to make functions in different files. So as you can see, we used this kind of things already before, like import the time module, import the render module. That is a module that stays in another file that you don't see it in your coding, right? So to define a module, basically you create a file. The file has a name, whatever.py, and inside you have defined your function. To use it, you just import that name, file name, right? The module name, and then you can call the function inside with the dot. So my module.greeting will call the function from this file, this function. So that's how the random module is done. Basically, there's a separate random file that's already installed on your computer with the Python together as a standard library that contains a function called random.int to give you the random int function. So this is how you use a module to organize your code. So you can also have variables in a module, person1, for example. Then when you import, you can use the same dot to get that variable. So this is basically the way to do functional programming in Python, because then you have the way to have a lot of different files, to have different functions in those files to group things together. For example, your room, right? In your game, you can say this is a room module. Inside there's a variable rooms, which contains the list of all your rooms. And then there's a function called get me a random room. Then it returns one of the room from that random room variable. So that's how you can use modules to manage your code. So you have different files, and then that way, even your project grows bigger and bigger, you can manage your project file by file and then function by function. That way, when you're coding, you just focus on one function inside of one module and then do your small things, and then that will be called outside. Then when you use it, it's like using Lego pieces and together to group together and become your big project. I think we have talked about those building modules, like this one's platform, but we've talked about those standard libraries before, like render module, like datetime module, all those things, right? So last time I asked ChatGPT,
so maybe you guys can pause the video and then just read this.
Yeah, you can just read this. What the ChatGPT thinks the good things about functional programming. So pretty much whatever we have said a lot about already.
So that's it.
But usually, as it says, we will use functional programming together with other programming modules. So in a complex project, you usually have multiple ways of doing things, even different languages together. So that's all for today.
So
next time, I think you can use this to make your gaming code more organized.
So bye guys, and hope you guys enjoy this video. It's so long. It's good.
A lot of information in this video, but that's
it.
It.
I'm going.
Bye.